Hi guys, welcome back to our channel. This is Harshita here and today we'll be talking about programming k-nearest neighbors algorithm in Python. So let's get started. Firstly, we learn what is a k-nearest neighbors algorithm. So basically this is a supervised learning algorithm that can be used for both classification as well as regression. In the case of KNN classification, the test instance is assigned the class of the majority of its k-nearest neighbors. Now how do you find these k-nearest neighbors? We'll be discussing this in the further part of the video. In the case of KNN regression, the output value of the class of the test instance is typically the average of the value of its k-nearest neighbors. Now you can read about this k-nearest neighbors algorithm in the article that has been attached as a link in the description below, and that article would definitely help you get a better understanding of this k-nearest neighbors algorithm. Then we can move on and you can learn about how to code this algorithm. Okay, so now we'll discuss about the pseudocode of k-nearest neighbors algorithm. So basically what happens is that we load the training data set as we do in the case of all the algorithms, right? Okay, and then we initialize the value of k. Now this k has to be chosen very carefully so that the decision boundary that has been formed by the algorithm, it is neither too complex nor very simple. Okay, and then we have to find the predicted class for the data point, right? Test data point. So what we do is that we find the Euclidean distance of this test data point from each of the points in the training data set, and then we select the top k data points in the training set which are nearest in terms of Euclidean distance to the test data point. Okay, and then from these top k training data points we find the most frequently occurring class, and that class is assigned as a predicted value of the class to this test data point. And this is how this algorithm works. Okay, so now this is a sample image, and you can see the variation of the decision boundary as k increases. With k equals to 1, the decision boundary is very complex, and with k equals to 25, it is very simple. So we need to choose a k that produces a decision boundary that is neither very complex, which we call as overfitting, and neither is very simple. Okay, so yeah, definitely if you read the article that is attached in the link in the description, so you'll be understanding KNN better. So let's get started with the code of the KNN. So firstly, we'll be coding this algorithm from scratch in Python. So I'll show you the main function firstly, and then we'll be explaining in detail each of these helper functions. So firstly, we have to prepare the data. We have this training set and the test set, which is definitely empty because we have not yet loaded the data in these data sets. Split is declared to be 0.67. So what is the split? Split is basically the ratio in which we want to split our holistic data set into training set and the test set. So firstly, I'll show you how does the data set look like. So this is basically a flowers data set which has three different kind of classes. 1, 2, and 3, right? So in each of the data point in this flowers data set, you can see that there are 4 numbers in the beginning, and then there is this class of this instance. So this is how the data set looks like, and we'll be using this data set in our code. Right, so basically we have this holistic data set and we want to split it in the ratio of 67%, 33%, where the 67% of this data set goes into the training set and the remaining 33% goes into the test set. So we use this load data set function. I'll be explaining this in a while. And then we have to generate the predictions. So we have this KNN predictions list which is empty as of now, and then we choose k to be 3. Now we can select k to be any value of our choice. You can just tweak this value, and yeah, this code that we are using here, it is all present in the description attached in the video. So you can download all these code and can use it. You can tweak the value of k, you can tweak whatever you want and experiment with this algorithm. So you can download this code for the same from the description. Okay, so let's continue. And yeah, so k equals to 3 we have chosen right now. And then we have a loop for all the test instances. Basically this loop is for x in range of length test set. So we have this neighbors list. So basically for each of the test data point we have to fetch its neighbors, right? We discuss the same in the pseudocode. So this is what is happening. We pass this training set, which is set of data points, and then we pass this test instance, and then we pass this k for this fetch neighbors function. Then we fetch the response from this neighbors list. This is the result. And then we have this list, right? KNN predictions list. So basically this list contains all the predictions that we find for each of the data points in our test set. So we append this result in this list. Then we find the accuracy and we print the accuracy, right? Now I'll be explaining each of these helper functions. So firstly we'll start with the load data set. Okay, so this load dataset function, basically the job is to split the holistic dataset that I just showed you into the training set and the test set using the split that we have defined, which was 67%, 33%. You can definitely tweak its value as well. So firstly, we open this file, which is essentially a CSV file, you can see. And then we read it line by line, and then we actually load this data into the training set as well as the test set. Okay, so you can see there, right? You use the split and append it. Okay, so this is how the loading of the data set works. Yeah, after that we have this function of calculating Euclidean distance. But this function is used inside the fetch neighbors. So I'll firstly explain the fetch neighbors, and then from there I'll explain how the Euclidean distance is calculated. So in the fetch neighbors function, you can see that there is a training set, which is the set of all the data points of the training set. Then there is this test instance, and this is the k. So for this fetch neighbors function, we actually find out the k nearest neighbors for this test instance that has been passed into this function. So there's this distances list, which is empty right now. And then you can see that the length is basically length of test instance minus 1. So you must be wondering that why is this happening? Okay, you'll be understanding this as we go through this code. So here we have this x in the range of length training set, right? Because we have to continue to find the distance of the test instance from each of the training data points. So hence this loop is over the training set. Right, then we find the distance between the points. We use this Euclidean distance function. I'll be explaining that in a while. Then we pass the test instance, the training instance, the training set x. I mean, this is the training data point, because at one point of time, we have to find the distance between two data points, right? So hence two data points are being passed and this length is being passed. So this length, basically we have this length of test instance minus 1. So, okay, now I'll tell you why is this happening. Because you can see in the training, in the holistic data set, the length of each of the data points is 5, right? 4 numbers, and the last is the class. So basically, we need to find the distances using the 4 numbers, right? We don't need to use the class. So hence, this length that is being considered to calculate the Euclidean distance should be 4, because the first 4 are the digits. I mean, these are the numbers, float numbers, and last is the class, which we are omitting while calculating the Euclidean distance, right? And then we append this distance. Basically, we append the training set as well as the distance, because we need to know, right, that which training data point has what distance with the test instance, right? So we append that in the distances list. Then we sort this distances list according to the distance between the points, right? And then we have the neighbors list. So what happens is now we have these distances sorted, right? I mean, this list is sorted in terms of the distances of the training data point with the test data point. Now we find the top k training data points that are nearest to the test data point, and then we have that in the neighbors list, and then the function returns the neighbor list. Okay, now we'll explain calculate Euclidean distance function. Here it is. So we have this instance 1, instance 2, and the length. So basically, firstly, we consider the distance between the points to be 0. That is just an initialized value, right? Now for extend range length. Now you must be knowing in fact that this Euclidean distance. So basically, what is this? This is a root of all the square differences between the corresponding points in the instances, corresponding elements in the instances, right? So for example, if say one of the value is a test data point and the other is a training data point, so what will happen is that there will be a under root, and then it will be 5.1 minus 4.9 whole square plus 3.5 minus 3.0 whole square plus 1.4 minus 1.4 whole square plus 0.2 minus 0.2 whole square, right? So this is how the Euclidean distance is calculated, and this is what we are doing here. It's exactly the same. We return the Euclidean distance. Now I'll discuss what is this fetch response function. So basically we pass the neighbors list. So what happens is that the function of this method is basically to find the actual predicted class from these neighbors by using majority voting, right? So firstly we have this class votes, which is right now uninitialized. I mean, it is empty. It is initialized, but it is empty. Okay, then we have a loop which loops through all the neighbors in the neighbors list that we extracted above, right? And now we have to find the response. So basically we see that a response is the class that should be predicted, right? So for each of these neighbors we have this response, which is the class of that neighbor. So if that class is present in the class votes, then we just increment the number of the basically the count of that class in the neighbor set, right? So we increment it by 1, or else we declare it to be once if it has occurred for the first time. And then we sort all this class votes dictionary as according to the number of times each class has occurred. Then we return the most frequently occurring class. So that is basically the predicted value of the test data point, right? And then this is the fetch accuracy function, which is nothing but we are actually just seeing that how many predictions are made correctly, and then we find the percentage of the same, right? So this is basically how we have coded KNN from scratch. Now I'll just run this function. Okay, you can see that the accuracy is 97.91666%, which is pretty good for an algorithm. Let's run it again. Oh, now the accuracy has changed. Now you must be wondering that why has this happened? So let's get back to the code. Okay, so you can see that while loading the dataset, we are actually loading it randomly, right? Random. So basically these training sets and the test set are being generated randomly. So each time you run this code, you might find the accuracy to be different because there are different training set and different test sets that are being considered, right? So actually what happens is that we do this because we want to get an estimate of the accuracy of this algorithm that we have coded, right? So we can run this multiple times, and then we get different accuracies. We get an average of the same, and then we would get an estimate that how our model is actually performing. Okay, so this was that we have coded the KNN from scratch. Now trust me, you won't ever be using this thing unless and until you want to tweak the algorithm itself, because we are techies and we are so obsessed with libraries, trust me. So because there are so many machine learning libraries, you'll be using one of those libraries for this KNN algorithm as well. So I have coded the KNN using Sklearn, which is a very famous Python machine learning library. So you can see that the code is so much shorter. It's just 53 lines here, whereas when we coded it from scratch, it was 80 lines, right? So the code has become so much shortened, and so yeah, we definitely prefer using the libraries unless and until we want to tweak the algorithm in itself. So I'll explain you what I have done. So basically, firstly, I have imported all the relevant libraries. Okay, so this is basically a website of Sklearn of the k-neighbors classifier, which is essentially the k-nearest neighbors algorithm in the library form. So you can have a look at this website and you'll get to know better how to use this classifier in a code. I have given an example for the same. Okay, so let's get back to the code. Yeah, so you can see the changes. Load dataset is slightly changed. I'll tell you what the change is. In the main function is also slightly changed. Fetch accuracy is as it is. There are no changes there. Yeah. So basically what happens is that this k nearest neighbors classifier, right? This k neighbors classifier of sklearn, you can see that this we have chosen k equals to 3 here also. So this model basically, we need to firstly train the model, right? So what happens is that these parameters that the model takes while getting trained, so basically they have to be numpy arrays. So we have to convert our arrays into numpy arrays before fitting them into this model. And yeah, one more thing, like in our previous code, we were just using the training set and the test set as it is, which were having the data points as it is from the data set. But here we have to slightly modify it, because when we actually train our model, which is from the sklearn, so we need to give it a array which has the training set points without the label, and then we have to provide another array which has the corresponding labels of the data points, right? So we have accordingly modified our code for the same, and then we have to convert it into numpy array, right? So this training set points and these are converted numpy arrays, and these the you can see, right, the training set points, training set labels, and also while loading the data set we have taken care of all that. I'll be just explaining that in a while. Okay, so then we fit this model with our training set points and the training set labels, right? And then we again have this range over the test set, right? And then we find the predictions using the model, and then we have this predictions in our knn predictions list, which was empty earlier. Then we find the knn accuracy as earlier. We print the accuracy. Now I'll be explaining the difference between our new load dataset function for the sklearn code and its difference with the previous load dataset function. So essentially it's all the same except these things, because we have to definitely split our data point into the point and the labels, right? So I have done that. You can see the same, and then I have used in this code, right? This code is also attached in the description of this video, so you can download this code and use it for future references. So now let's just run this code. Accuracy of 96.078%. Nice. Now let's run it again. Different accuracy. Why? Because again we are using this random splitting method. So again, as I just mentioned before, we can find different accuracies for several cases. Say we run this algorithm 10 to 12 times. Each time we'll be getting a different accuracy. We can average out these accuracies, and then we can actually get an estimate of how our model is actually performing with the real world scenarios. So that was it that I wanted to discuss in this video. I hope you found this useful, and do let me know about any other topics that you would like to have video tutorials on, and mention them in the comments of this video and we'll try to cover that. And if you like this video, do give it a thumbs up and subscribe to our channel. Have a great day. Thank you.